right. Good afternoon. My topic is on heads-up computing. It's very similar to some of the earlier talks on the wearable digital and intelligent assistant. So what that is, I will first just play two short videos about two of the pieces of work. One is the Panda Lens. Let me try to speed up a little bit so we don't waste.
We introduce Panda Lens, a proactive AI narrative documentation assistant designed for OHMD or AR smart glasses. Panda Lens first observes various contextual cues from user behaviors and the environment to identify potentially interesting moments and automatically captures them. Users still have control, complementing AI assistance. Once users confirm their interest by commenting on these moments, Panda Lens transcribes their comments and combines them with other data such as images, audio, timestamps, and locations to compile comprehensive contextual information. Leveraging the multimodal contextual information with the large language model, Panda Lens presents context-related queries to users to enhance their ability to express themselves and facilitate their writing. After the journey, it empowers users to choose their preferred moments. Then, it generates a draft document using previous contextual information and LLM, and allows revisions according to the user's preferences. Now back to John's adventure with Panda Lens. As he gets closer to an intriguing dry leaf, Panda Lens detects his movement and prompts him to comment. It recommends John, who loves birds, to comment when it detects bird sounds, but John ignores it, which gradually fades away. When seeing a giant dinosaur skeleton at the museum, John wants to capture good photos of it to share. So he uses a ring mouse to manually take several shots and finds several good spots to reframe the photos. Now John's interest is attracted by a microscope. The system automatically captures a photo when it detects his prolonged gaze on it. To avoid disrupting his observation of bacteria, the system delays showing the photo until John is finished. Then it invites him to comment
such high resolution of bacteria in a microscope.
And asks a follow-up
Did you use
question.
such a high-resolution microscope in your past school life?
Have you used some low-quality microscope?
John likes these questions tied back to his past experiences, which is his preferred question style, so he replies to them. After the trip, the system provides a list of recorded moments and enables John to verbally select favorite moments.
Like all of it.
Then generates a blog based on the selection.
Walking into the renowned Natural History Museum, I was immediately captivated by the world's largest flower.
Back home, John can check the blog on his laptop, which is exported as a Word file. This allows John to make further edits if he desires. In the end, John can share the edited blog with images on any platform.
All right, so that's just one example. Let me show you another example.
We introduce
We introduce iGet, a proactive wearable assistant with AR smart glasses and a ring mouse, helping users rediscover hidden yet desired knowledge in their environment and transform everyday moments into learning opportunities. iGet continuously monitors user gaze and environmental context to identify knowledge opportunities. Using such multimodal data, iGet uses the context analysis agent on the multimodal large language model to identify gaze patterns, primary activities, and label interesting entities, determining if they are in focus. It also analyzes the user profile to link these entities with relevant knowledge that may interest the user. iGet then employs a knowledge generation and selection agent to generate interesting knowledge based on the contextual data. It references relevant historical knowledge and user profiles to avoid repetition and fine-tune the knowledge topics and expertise level. The agent generates factual, conceptual, and procedural knowledge for entities in both the user's primary and peripheral vision, balancing between unseen entities and seen but unfamiliar entities. To ensure high-quality knowledge and prevent information overload, iGet uses a weighted scoring system that prioritizes knowledge based on novelty, aligned with user interest, utility, and unexpectedness. Finally, it selects no more than 2 high-scoring pieces of knowledge that align with the user's learning intention. After generating knowledge candidates, iGet checks the history again to filter out similar content. To ensure users can easily absorb the knowledge with minimal disruption to their primary tasks, iGet uses output transform agents to deliver the information in a multimodal format. It provides visual elements like keywords and emojis for quick understanding, an image reference with bounding boxes to help locate ignored or unfamiliar entities, and audio feedback for detailed information.
The spider lily near the entrance is poisonous if eaten, especially...
Upon receiving the information, the user can use the ring mouse to perform follow-up actions, such as asking additional questions. While using the same system pipeline, users found that iGet takes on different roles and addresses previous knowledge acquisition challenges in various scenarios. When shopping, it helps users overcome hesitation in trying unfamiliar products by providing personalized information, such as comparing the flavors of 2 Japanese grape gummies, enabling informed decisions. In museums, it helps users extract key information and expand their personalized knowledge base, preventing information overload, like identifying a bird as a coastal species relevant to the user's seaside hometown. During casual walks, iGet becomes an environmental storyteller, sharing surprising facts users didn't realize they didn't know, like 2 familiar walls on campus are actually part of the Berlin Wall.
All right, so these are just 2 examples of what we believe once we have what we call heads-up computing that can actually happening in the near future. So one thing I want to argue here is that capabilities defines interaction, right? The emergence of integrated human AI entities from separate systems, what we have right now, which we have our phones, we have our desktops, which kind of not really integrate with our body, will be towards in the future a seamless integration. And this will create a new class of system where human cognition and artificial intelligence are blended seamlessly in real time. And the future of interaction lies not in device we use, but experience that augment who we are. All right, so with that, I would like to introduce the concept of heads-up computing, which I believe is one way of, in the future, that how we actually going to have experience with our computers and with intelligence. So heads-up computing is defined as an embodied interaction concept aimed to provide just-in-time computational assistance without disrupting daily lives. And the key features including embodied head and hand pieces for everyday use, multitask-friendly, adaptive, intelligent interfaces, and multimodal synergetic interactions coordinated with daily activities. The goal is to seamlessly integrate human-computer interactions into people's lives. And you see those examples earlier. All right, of course, why do we need that? Let's look a little bit into the human-tool coalition, which go back to Andrea's talk, right? So as mentioned by Andrea already, we invent tools to solve our problems. The tool go back and shape our lives. And if you don't design the tool properly, it will shape our lives into some undesirable ways, right? Like what we have in the desktop computing as well, mobile computing, what we call smartphone zombies, as well as sedentary in the office creatures or couch potatoes. So if we want to invent something new, we need to think about not only what it can do for us, but also like how does it shape our lives. And my vision is that it will be nice that the future interaction allow us to thus work anywhere in harmony with other life activities and is healthy and much more enjoyable. Okay, so what is the problem of existing tools, right? There are three problems. One is the device is centered. Second was they have resource conflicts. And third is attention demanding. So heads-up computing try to aim to solve these problems with the overall goal, which is try to seamlessly blend that into our lives. And the approach including the following. First, instead of a centralized piece of hardware, we want to build things that's distributed. We use human-centric instead of device-centric, and we have hand piece, and potentially a body piece. And we use multimodal interaction instead of mouse and keyboard. Input using voice, eye tracking, and subtle hand, finger, head gestures. And output use optical head-mounted displays plus multimodal. And we need to design interface that's fragment attention-friendly as well as resource-aware. So the static ones will be fragment attention-friendly, and then the dynamic ones can adapt its interface according to the environment and task you're working on. So let's look at each one by one. So what do we mean by human-centric instead of device-centric? So if you look at the picture on the top, you can see that when we use our phones, when we use our laptops, the device in the center, right? Because why? All the input and output is centralized in one piece. So we need to accommodate our body input and output for those devices. But if we distributed that to our input and output, then we can have a human-centric design. And then why we have head piece and hand piece? So if you look at this, right, you probably don't see it, but if we show you what the human brain is actually responsible for, you see that we have two hot zones, right? Our head and our hand. And our head is responsible for providing real-time visual and auditory feedback, understanding what human sees and hears, understanding facial gestures and emotions, understanding attention and speech input. Our hand piece is responsible for providing real-time haptic feedback and tracking hand positions, postures, and movement. One is our sensor, the other one is our actuator, right? The head is also our actuator as well. Okay, so why do we choose a different way of input and output? The reason is that existing systems, if you look at what we're doing daily, all the activities we do actually heavily rely on our hand and our eyes, right? So these data activities are hands and eyes busy. If we do HCI tasks, also hands and eyes busy, we have a conflict. So we should looking for complementary ways to do it. And then, what do we mean by the interfaces, right? So first one is, this is a paper by NT, which is a classical paper about 4-second burst. Basically, it says that in the mobile environment, we only have a burst of 4 seconds for attention to doing things as HCI. So with that, we need to design what we call fragment attention-friendly interfaces, right? That's the norm. And also, we have eventually want to define dynamic interfaces that based on the available resources people have. So in the environment, we have human resources, and the activity requires something, and the environment constraint requires something. Then what's left should be what the HCI task should be allocated to. But that changing from time to time. So how do we design dynamic interfaces? That's a key problem. All right, so we're going to talk about key challenges of fundamental problems. Well, the first one is hardware, right? The reason you don't see these things existing on your using databases is because we need devices that's very lightweight, have wide good appearance, battery life lasts for like a day, and then cost reasonably and have good functionalities. To my knowledge, we are closer, but not still be able to build something like that yet. But to me, that's a good thing because it gives researchers some time to figure out the problems. All right, so what are some other key challenges, right? So I'm dividing it into, first thing, what to present, information transformation and context. First of all, content must be dynamically adjustable to situations, contextual relevance across diverse environment, and balancing information richness with qualitative economy. And also when to present, timing and interruptions. This work has been done a lot in the mobile as well as in the desktops, but in the real world, it's still not well studied, right? And then how to present and interact. What are the modality, the form, the input and controls, when you select the right modalities or modes of interactions and design perceptual, efficient information formats and create natural presentations. And what I think the fourth one is really important is that a lot of times we only study what we call the short-term effects. But those devices, if you want to talk about how they shape our lives, they are long-term, right? I really want to see some long-term effects, seeing how these devices can potentially change the way we live and psychologically, mentally, and health, everything. All right, so what are some of the kind of key problems, right? So one thing is the real-time adaptation to context. How to dynamically adjust content, timing, modality based on contextual relevance, environment, user goals, cognitive states, while ensuring perceptual efficiency. And then how do you balance autonomy and control, right? How to design systems that respect attentional boundaries and avoid disruptive interruptions while still delivering timely, actionable insights. Multimodal integration constraints, how to select and combine modalities as effectively with overloading sensory channels. And it's great to see that Pedro has other means of doing actuations. I think we need to study how these things work together. And then finally, predictive versus reactive. I think currently the AI is still reactive, which is not enough. Human brain actually doing tons of prediction every time. That's why we can act much faster. AI needs to capture that. If it's always reactive, it will never be fast enough to be used by human. All right, with that, I will leave this for questions.
So yeah, really inspiring. I love this notion of heads-up computing. It's like a heads-up display for the addition domain. So just a pure technical question. In fact, there's two. One is about the latency. You can imagine that the system does not react on time. It could be a problem. Another one is this seamless interaction, so that if the information is not displayed at the right time, it's not good. And also, if the user has to do many times the same action, so how can you report on that? So this notion of the system needs to be responsive, but also it needs to be reliable. So.
Yeah, that's really hard, actually. I think one thing that we learned is that you need to give the user the ability to annul and correct really easily. So one thing what we did in the Pendulance, as well as IGET, is that we try to suggest proactively some information for you to interact with. But we need to do it in a very subtle way and then do it in a gradually way so that user can ignore it or just quickly undo it if they wanted to. With that design, user become much more receptive. And then if you increase the benefit rates, like at least 4 or 5 times, if user find it useful, and then where it's not useful, it's not that annoying, then it's better. Yeah.
So I don't want to take the time, but there's also this co-adaptation that needs to be done, so that the system has some responsiveness and also some way to use with it, so that they both adapt. I mean, it's more like the users that adapt to the system. It's usually what we also had as an user experience.
Yeah, I think co-adaptation is. I mean, I think this is also the insight. I was kind of watching some of the other talks, like Brian's, talk about the intermediates. When you design something, to me, I feel like the end goal is not necessarily as important, especially in the creative process. It's the intermediates. Like human need to have a dialogue with intermediate. You need to have a way to allow AI to quickly generate all these intermediates and allows you to quickly go through and then interact with that. to allow you to move to the final thing. I see some interesting works that people try to turn the LLM into something programmable, into a simple language, so that you can interact with it much more easily and more controllable. Right now, LLM is not controllable, right? You think you can do a lot of things, but if you want to do it, the things that you exactly want, it's extremely hard, right? So how can we make LLM controllable, right? And then transparent and generating intermediates, and instead of like replacing humans' work, but more facilitating working with humans. I think that's a very interesting topic.
So I think heads-up computing is a paradigm, right? It's like vision or anything. If given we have some industry guys here, if you want to apply that into the real, right, really deploy some real systems, which specific application domain that you want to start with, you want to really penetrate in? Do you have any specific examples?
Thank you. Question. By the way, there's 2 videos actually co-authored with Professor Huang here. Well, that's a question that people ask me, what is the killer app? To me, I think my guess is communication is one, right? If people doing WhatsApp, doing WeChat, like that's part of their life, and if you can do this in a kind of a seamless fashion, I think that will be a selling point. And then another thing you learn from the internet, what's the first search engine first get popular because people searching for porn videos, right? I'm not saying that, I'm saying entertainment. Entertainment, I can see a place of opening like new AI type of games where you play this, how do you call that? Some people play these Nintendo games where you're kind of exploring the wild and doing all that kind of stuff. I think if you do it in the real world, it can be really interesting. So I can see that can be another route going. And then there's a lot of special market for this kind of task for learning and doing some work. So that's what I will suggest. Thank you.